Okay, let's go into reducing fractions. Okay, so all reducing is dividing the top and bottom numbers in a fraction by the same number. Okay, so for example, if we wanted to reduce 4 over 20 to lowest terms, okay, there are two simple steps to this one. The first step is to find one number that divides both numerator and the denominator without leaving a remainder. And then the second step is to keep dividing the two numbers until by the number on step 1, until you can no longer divide. Okay, so this is what I'm talking about. Let's try to find a number that divides 4 and 20 without leaving a remainder. The one I can think from on the top of my head is the number 2. 4 divided by 2 is 2. 20 divided by 2 is 10. Okay, so we're done with step 1 here virtually, but if we go on to step 2, it tells us to keep dividing these two numbers by that number until you can no longer divide. So we ask ourselves, can we still divide by 2? If the answer is yes, then we divide by 2. We divide the top number by 2, which would equal to 1, and then the bottom number also by 2. 10 divided by 2 equals to 5. Okay, so then we go back to the second step. Can we still divide this? Not really. We can divide by 1, but 1 divided by 1 is still going to be 1. And 5 divided by 1 is still going to be 5. So there's no use in us dividing by 1. There's really no other number we can use to keep dividing this fraction. So in the end, the answer is 1 over 5. Okay, now there's several ways to do this. You could have started out with 2, and that is totally fine as long as you get the answer. Or if you can think of a larger number that can divide both of these evenly, then you'll save a lot of time. So let's think of another number bigger than 2 that can divide 4 and 20. Off the top of my head, I can think of the number 4. Okay, so 4 divided by 4 is 1, and 20 divided by 4 is still 5. Okay, and as we know, we cannot keep reducing this fraction because we already tried it by 2, and we already tried it by 1, and it gives the same answer. So the answer to this one would be 1 over 5. Okay, sometimes you might need to divide by different numbers. For example, you might first need to divide by a fraction by 4 and then realize that you can still divide by 2. When that's the case, just keep dividing, remember. Always keep dividing until you can no longer find any numbers that go into these two. Okay. Video on the greatest common factor. We find that we can also reduce a fraction by finding the greatest common factor of both the top and the bottom number. By the way, if you haven't seen the GCF video, I highly recommend that you do, because it teaches you how to get the factors from both numbers. I think I've only seen a couple of questions on it on the GD test, but it'll help you a lot when trying to reduce and on future lessons like adding and subtracting fractions. That is going to be right after this video. So take a look at it. So going on with this fraction, if we use GCF, if we try to find the greatest common factor of 4 and 20, okay, if you remember, this is how we find it. We find numbers that when multiplied, two numbers that when multiplied give you 4. That's the number we're going to start off with. So 1 times 4 gives you 4, okay? And then after the 1, 2 actually times 2 gives you 4. But because 2 multiplied by itself gives you 4, we don't write it 2 times. We only write the 2 one time, okay? And since it was 2, and then this is really close to 4, we know that 4 isn't really divisible by 3 by any number. So these are the factors for 4. Okay, so let's move on to 20. What two numbers, when multiplied together, give you 20? Well, at the top of my head, I can think of 1 and 20. Then 2, actually, and the number 10. Then after that, I can think of 3. No, 3 does not divide evenly into 20. 4 and 5. And then after 4, there is 5. But then when you multiply, divide 20 by 5, it gives you 4. So we don't have to write that again. Okay? So the GCF, what the GCF asks for is to identify the greatest factor among these two numbers that can divide these two numbers evenly. So, or rather, without remainder. So we find that the greatest common factor in these two is 4. Okay, so how do we use the greatest common factor to actually reduce this fraction? Okay, well, we use it like so. We divide the top number by 4. Okay, and as we remember, we get 1. Okay, and then we divide the bottom number also by 4, right? Because the rules state that we have to divide both of them by the same number, and 20 divided by 4 is 5. Okay, and that's how you use the greatest common factor to reduce any fraction.